Okay, so this is going to go through the problem on page 3 of our notes, which is to sketch a complete graph of the function f of x equals 4x over the square root of x minus 3. This will take a couple of videos because it's a fairly long problem. Okay, the first thing I always ask you to do is think about the domain. So the problem with this one is that it has this square root of x minus 3 in it. So if you have a square root, you have to worry about domain. What I know is that what's under that square root has to be normally greater than or equal to 0. In this case, because it's in the denominator, it has to be greater than 0. So that means my domain is going to be the set of all x such that x is greater than 3. Okay, number 2. The next thing you were asked to consider was the x and the y intercepts. Okay, for the x-intercepts, you let y equal 0. If you let y equal 0, you've got 0 equals 4x over the square root of x minus 3. That means that you would want the numerator 4x to equal 0, which would lead to x equals 0. But x equals 0 is not in our domain. So what that means is there are no x-intercepts. Okay, for the y-intercept, you're going to let x equal 0. But again, x cannot equal 0. It's not in our domain, so there is no y-intercept. So this is a problem that has no x-intercept and no y-intercept. It does not cross either axis. Okay, next. Next thing we were concerned with was asymptotes. Okay, so in terms of a horizontal asymptote, what we want to do is take the limit as x goes to infinity on 4x over the square root of x minus 3. If we think of end behavior, that's the limit as x goes to infinity on 4x over radical x. Since the degree of the numerator is higher than the degree of the denominator, this is going to head to infinity, so there is no horizontal asymptote. Now, for vertical asymptote, we haven't talked a lot about this. Mostly we've just talked about where it would make the function undefined. And we can see that this function would be undefined at x equals 3. But x equals 3 then is not in our domain. Well, that's normal for vertical asymptotes. So we might think that x equals 3 is a vertical asymptote. We're going to come back and revisit that question in just a little bit. Okay, the next thing we want to do is we want to investigate the first derivative. So we want to do a first derivative analysis. Okay, so we need to take the derivative, and I'm going to go ahead and use quotient rule to take that derivative. I'd like you to pause this video, do that yourself, then start it back up and see how you did on your derivative. Okay? Pause. All right, now you're back. So in taking the derivative using quotient rule, it's the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator over the denominator squared. Okay, if I work that out a little bit, that's 4 times x minus 3 to the 1/2. And then that's going to be a minus 2x times x minus 3 to the negative 1/2 over x minus 3. Then what we want to do is we want to factor out the greatest common factor. And when you factor out a greatest common factor of an expression like this, you're factoring out the lower of these two powers. So I can see the greatest common factor, first of all, would have a 2 in it. And then the lower of these two powers would be x minus 3 to the negative 1/2. In the first spot, that would leave me with a 2 times an x minus 3 to the first. In the second spot, it would leave me with just an x. Okay, and the denominator would just be x minus 3. Okay, this x minus 3 to the negative 1/2 can be moved to the denominator and join up with that x minus 3 down there. So now in the denominator, I have x minus 3 to the 3/2. In the top, I have 2. And if I simplify what is in here, distributing this 2, I get 2x minus 6 minus x becomes just x minus 6. Now what I want to do is set that equal to 0 or undefined. Well, it will be undefined when x equals 3, which is not part of my domain. It will be equal to 0 when the numerator is 0, which means x will equal 6. So now I'm going to do the number line sign chart for f prime with x equals 6 on it. Remember, my domain, though, is that x has to be greater than 3. Okay, if I pick a number between 3 and 6, like let's say 5, the numerator will be negative, the denominator is still positive, so that's negative. pick something over here like 10. The numerator's positive, denominator's positive, so that's positive. So now I can write my first derivative conclusion. So my conclusion is that f is decreasing on the interval 3 to 6. F is increasing on the interval 6 to infinity. And f has a relative minimum at 6 something. Now remember, to find the y-coordinate, I'm plugging 6 into the original function. So if I plug 6 into this original function here, 4 times 6 is 24, 6 minus 3 is 3, so I get 24 over the square root of 3. So that's going to be my y-coordinate for that point, 24 over the square root of 3. And there's no relative maximum. Okay, that's the end of my first derivative analysis. And on the next video, I will do the second derivative analysis.